Okay, welcome to Unit 1, Lesson 2. This is going to look a little different than the other couple of lessons. I'm recording this on some new software here. If you watched the walkthrough and orientation video, then you know you can expand this. This video is going to appear pretty small in your window, but if you look in the actual video screen in the bottom right of the rectangle, there's a button you can press that will enlarge it to full screen, and this one should actually show up fairly clearly full screen. So you can see our first objective. We only have one objective for this. We're introducing factoring polynomials, and we're factoring polynomials of the form x squared plus bx plus c. Now let me emphasize here, b and c, these are just numbers. We have a letter there right now, but that's because we don't know what number it is. Okay. Somehow I got some random marking down here. Let me clean that off. But b and c are just numbers. B is whatever number is in front of x, and c is the constant, the number that's out there being added by itself that does not have an x attached to it. You'll notice there's not a number in front of x squared. All of the polynomials we're going to be factoring today in this lesson will only have one x squared. We'll deal with ones that have numbers in front of the x squared in the next lesson. First, let's go backwards. Remember a polynomial like this. Let's say you had x plus 4 being multiplied times x minus 1. Hopefully, you remember the phrase FOIL. FOIL, F-O-I-L, stands for, and I'm going to go down with it here, first, outside, inside, last. In other words, first means let's take the first term in each pair of parentheses. Well, x and x are my first terms. They're first in each pair. So we're going to do x times x. We're going to multiply. Well, that's just x squared. Of course it is. All right, then let's do the outside two terms. Well, we've got four terms here. All right, we've got an x. Let's draw an arrow down. We've got an x. We've got a 4. We've got another x. And we have a negative 1. There's our four terms. Well, the two that are on the outside, if you just look at my arrows here, that one and that one are on the outside. You got 2 in the middle, 2 on the outside, so we're multiplying the 2 on the outside. So that's x times negative 1. Well, that's just a negative 1x. And you can write that as negative x. You do not have to write the 1, but you can if it helps. Alright, then we're going to do inside. Well, if those two were the outside, then the other two must be the inside, the 2 in the middle. So that's 4 and x. Well, 4 times x is just 4x. Notice there's a plus or a minus sign in between each step of FOIL. So we're separating each of these terms with a plus or a minus depending on what the terms turn out to be. And then last is the last. It's the opposite of first. So it's the last term in each set of parentheses. We've got a 4 and a negative 1. I know I just made a confusing hammock-looking thing there, but hopefully you can follow what's going on. 4 times negative 1 is just a negative 4. Okay? And now I have two terms here that can be combined. After I've FOILed, I can now combine like terms, and my final answer would be x squared minus 1x plus 4x is a plus 3x, and then minus 4. And that would be my final answer. That is what I should get. This is what I should get when I multiply x plus 4 times x minus 1. Okay, that's going in the forward direction. That's FOILing. But what if you were given this over here? You were given this trinomial and you were asked to go backwards. Factor it. Break it down into its factors. And the reason this is really helpful is because ultimately this is going to lead us to quadratic equations. And when you're dealing with quadratic equations, they're set equal to 0. And if we can write something as a couple of terms being multiplied instead of a bunch of things being added, we make our life a whole lot easier. But don't worry, you'll have plenty of time to catch up on that when we get there. So, let's just bring this exact same polynomial down here. Let's just look at it again. X squared plus 3x minus 4. Now turn your brain off and pretend that you didn't know what factors this came from. You ought to know because they're right up there. There they are. That's what our answer is going to be. But let's think about how we could get that from this information that we have. I'm thinking FOIL in reverse here. That's what you're thinking is, can I FOIL two factors and get this polynomial? Well, let's look at it. Set up our two pairs of parentheses and think FOIL. Okay, I've got it listed right over here first. So whatever's here and here is going to have to multiply to give me this over here, this x squared. Well, then that's got to be an x and an x, because x times x is x squared. Okay, now the next thing I do, you might think, okay, let's look at the 3x next. Well, let's actually skip to the last term. If you skip to this minus 4 here, this is what you look at next, because this tells you about the signs. Well, the fact that this number is negative, we know that we're multiplying whatever number is here times whatever number is here, and it's going to give me this negative 4. So think about what that's telling you. You multiply two numbers and you get a negative. Well, that means one of these numbers has to be positive and one has to be negative. That's the only possible way you can do this. The only way you can multiply two numbers and get a negative is if one's positive and one's negative. Because think, if they were both positive, the 4 would be positive. If they were both negative, the 4 would be negative. The 4 would be positive. Right? Because a positive, my pen's malfunctioning on me here for a second. Okay, let me clear that and try again. That is kind of ugly. Let's try this again. A positive times a positive is always going to be a positive. Well, a negative times a negative is also always going to be a positive. So if I want a negative answer, I've got to have either a positive times a negative, or I've got to have a negative times a positive. Either one of those will give me a negative answer. Okay, so that's why I say right here, that plus and that minus, I know I have a plus and a minus because this last term was negative, because of that negative right here. I know I'm drawing a bunch of arrows all over the place, and I'm going to clean this up here in just a second. Let me go ahead and clean it up now. Let me get rid of all this action here. Don't mind me, I'm just erasing. And let me clear out these arrows so this is a little cleaner. Okay, so we know we've got a positive and a negative, and it's got to multiply to make negative 4. Well, now, to figure out what numbers actually go in these blanks, we've got to think, well, it still has to add to make this middle term, though. This 3x. We have to be able to get 3x from these two, because think, I'm going to come over here. Remember, where did that come from? It came from when we combined the outside and the inside terms. Another way to look at it, I'm going to go from this example that's directly above it. This negative 1x and this 4x combined to give me 3x. I got that from my outer and my inner product. So let's look at factors of 4. You probably, you figured it out already. 4 could either be 2 times 2, or it could be 1 times 4. Those are my only two options. Well, which of those pairs would also add up to a 3 if one was positive and one was negative? Well, obviously this can't work because 2 minus 2 is 0. That's not going to work, so we can't use that. It's got to be the 1 and the 4. So now all we got to figure out is which one of them has to be positive. Well, since the middle term is a positive 3, I know I need the bigger number to be positive. So I want a positive 4 and a negative 1. Right? Now you can check it. You multiply it back out. We already did multiply it back out. It was our first example. Now I know I really labored over that and took a long time, but I want to make it really clear about the thought process of how you can pull this off. Alright, let me scroll down here and let's do some more. Let me give you another one. Let's say you had x squared plus 7x plus 12. Now this was a little nicer of me because it's all plus signs. So I'm going to start by drawing my pairs of parentheses. Again, I've just got an x squared in front, so that's going to be an x and an x. And since this is positive, what does that tell me? That tells me that both of these signs, the sign here and the sign here, are going to be the same. But then I have to look at this middle sign. Well, the middle sign, the 7x, is also positive. That tells me these are both plus, because they have to add up to a positive number, and they have to be the same, so they must both be positive. So now all that's left to do is figure out what factors of 12 also add to 7. Well, think about your numbers that will multiply to make 12. You got 1 times 12, you got 2 times 6, and you got 3 times 4. Those are your only options. Well, it's pretty clear. 3 and 4 add to 7. So we put a 3 here, a 4 there, and there is the factored form of that polynomial. You can check it. Do FOIL. If you FOIL this out, you will end up with exactly x squared plus 7x plus 12. Isn't that neato, burrito? It is, and I just made myself hungry because I said burrito. Okay. Let me see if I can come up with some more space. I'm going to keep going down. Let's keep going down. We can always add more space on the bottom. Okay, how about x squared plus 5x plus 6. Now, one thing I haven't mentioned yet, and I really should have mentioned by now, is there a GCF I can factor out? If there is a greatest common factor between the three terms, you want to pull that out first. You need to pull that out first. Because if you don't, you're going to get some huge answers. It's going to be really tough to work with. You need to pull out that GCF first. Well, if you look at this one, my three terms are x squared, 5x, and 6. No, there's not a greatest common factor. There's nothing I can factor out of all three of those. So let's just go ahead and do what we've been doing. Two sets of parentheses. I know I'm going to have x and x. Everything's plus signs, right? I've got a positive and a positive. That tells me I'm going to have two pluses over here. And now I just need to know what multiplies to make 6, but adds to 5. Well, 6 is either 1 times 6, or it's 2 times 3. Oh, well, my 3 got a little wonky there. Sorry. Oh, hello. Let's try that again. Oh, writing with a stylus on a computer screen, every now and then it gets a little ridiculous. Oh, well, I apparently cannot draw a 3. Wait, I will not give up that easily. Wait for it. There we go. Had to slow down on it. I didn't want to draw a 3. So, which one of those adds up to 5? Well, 1 plus 6 would be 7. That's out. 2 plus 3 is 5. So there we have it. X plus 2 times x plus 3 is the factored form of that polynomial. And I'm going to keep going down. Give me some more space. Alright, let's see if I can get you a good one. Where's a good one here to choose from? Oh yeah, here's one that looks a little bit different. I want you to see one like this. X squared minus 12x. Oh, there's going to be a minus on there, I promise. Plus 35. Alright, you haven't seen one yet where the second term is negative but the third term is positive. Let's think about what that means. First of all, is there a GCF? No, there's not. X squared, 12, negative 12x, 35, no common factors. Don't worry, you're going to see one in a minute with a GCF, I promise. I won't just keep saying that for nothing. Alright, so we've got an x here and an x here. Now let's think about our signs. We have a minus and then a plus. Well, remember, this plus sign tells me the signs are the same in the two factors. They're both positive or they're both negative. But now this negative tells me that when I add those two, it has to be a negative number. Well, then that means they must both be minus. And now this one's pretty straightforward. 35, there's only two options. You can either do 1 times 35. Well, still my stylus does not want to make a 3. Sorry about that. Or you can do 5 times 7. Those are your two choices. Well, obviously 5 and 7 would add up to 12. And a negative 5 and a negative 7 would add up to negative 12. And there you have it. Done. See, once you get the hang of these, they go pretty quickly. Alright, let's do one more like this, and then we'll look at something different. Maybe two more. The more the merrier. R squared minus R minus 42. Bunch of negative signs. Well, that means they ought to both be minus signs, right? No, don't make that assumption. Don't make that assumption. People make that assumption all the time, but if you think about it, it'll make sense why that doesn't work. R and R, we know that part. But now remember, the fact that this is a minus tells me I have a plus and a minus. Has to be. That's the only way you can multiply these two numbers and get a negative number. Alright, 42. Now 42 has several possibilities. You got 1 times 42. You got 2 times, well, wait for it, 2 times 21. 3 goes into 42. You got 3 times 14. Oh, my stylus is really acting up on me now. 4 does not go into 42. 5 does not go into 42, but 6 does. 6 times 7. Alright, now think about what we have here. We need which of these factors multiplies to 42, but if you added them, and remember one of them is negative, we've got a positive and a negative, if we combine them we get, well, what do we get? Look at the middle term, minus R. Remember, that means this is actually minus 1R. It's an understood 1, and my 1 looks ridiculous, sorry about that. It's the leaning tower of 1 there. But minus 1R, it's understood. So which of these pairs would subtract, essentially, to give me negative 1? This pair would right here. Now, it's negative 1, not positive 1. So think about it now. It matters which one goes with which sign. I need to have a positive 6. Well, if I could get my stylus to come back on for me. Positive 6 and a negative 7. Sorry there's so many kinks with the styluses. The more I use it, the more I'll get comfortable with it, and we'll have less of this nonsense of you having to listen to me talk to myself. But now, there's your answer. Multiply it back out. Think about if you did inner and outer. You would have positive 6R on the inside and a negative 7R on the outside, which does add up to our negative 1R we were looking for. So that works. So that's why that's our answer right there. Super. Alright. A squared plus 2A plus 10. Start to factor this here. Alright, I got my A. Now, positive 10, positive 2A, that means everything's going to be positive. Now think about your factors of 10. 1 times 10. You could also use 2 times 5. Those are my only two possibilities. Which one of these adds up to 2? Because our middle term is 2. You got 1 plus 10 would be 11. Or 2 plus 5 would be 7. Neither one of those works, does it? Nope. Neither of those works. This does not factor. This is called a prime polynomial. Not every polynomial can be factored. Just because we have a trinomial doesn't automatically mean you can factor it. This is prime. We don't have a way to factor it. So, we move on. You're done. You should like it when it's prime. That's less work for you. Alright, time to make it slightly more complicated. 2x to the 4th. Wait a second, I thought you said there wasn't going to be a number out there. Well, now there is. Minus 26x cubed plus 84x squared. This goes back to that GCF question. There is a GCF in this case. What is the greatest common factor? what would divide into all three of those terms? Well, you know a 2 would. They're all even numbers, so every term has an even number on it. All of those are going to be divisible by 2. Well, they all also have at least an x squared. We've got an x squared, an x cubed, and an x to the 4th. So they're all going to be divisible by x squared as well. So if I factor 2x squared out, I will now have something that I can work with. So let me do that over here. So let me factor out 2x squared, and then I'm going to open up my parentheses and say, well, what does that leave me with? 2x to the 4th. If I remove 2x squared, what's left? Well, the 2 is gone, and of those 4 x's, let me come over here and start with these right here. I had 4 x's, right? Well, now 2 of them have been factored out, so 2 of them are left. Minus 26x cubed. Well, if you divide 26 by 2, you get 13. And if you take x cubed and you pull out x squared, there's only 1 x left. And then 84x squared plus 84 divided by 2 is 42. And it had an x squared on it, but we pulled out x squared. So we pulled out both of those x's. There's no x left on that last term. So now we have a 2x squared out front, but all of this stuff that's in parentheses looks just like what we've been doing. So now we can factor this, just like the other problems we've done. So let's make sure we don't forget this 2x squared. It is out there. It is part of the problem. And then we can take this other polynomial and break it down. Okay, I've got x and x to make x squared. I have a positive 42. My last number is positive, but my middle number is negative, so both signs are going to be minus, and hopefully by now you know which factors of 42 would add to 13. 6 and 7 would add to 13. Negative 6 and negative 7 would add to negative 13. And there's your answer. Let's see, I think I'll squeeze one more in here. I know this is getting kind of long. Let me just squeeze, because I want you to at least have seen one that looks funny. Oh, I don't want to see one that looks funny, man. Why would you do that to us? Well, because you're going to see one that looks funny probably on the assignment. You will want to feel like you've been prepared. Alright, this looks all kind of goofy, right? It's all backwards. Well, guess what? We can flip it around and fix it. Rewrite it. Just reorder it. It doesn't matter what order you write the terms in as long as you keep the signs right. So if I just switch this thing around, I'll write it right below it. I can bring this 3m squared out front. I can leave this negative 24m in the middle, and then this minus 60 can go on the end. It doesn't matter whether we take it at the first or at the end. This is the exact same thing. I just rearranged it, and now it looks like something I can work with. Except you should notice divisible by 3, divisible by 3, divisible by 3. There's a GCF. Let's factor it out. I can factor out a 3. I cannot factor out an m because this last term, this 60, there's no m on it. So I can't pull an m out. You can only factor it out if it's in all 3 terms. So when I factor that 3 out, what does that leave me with? M squared minus 8m, 24 divided by 3 is 8, minus 60 divided by 3 is 20. And now, this shouldn't be too big of a deal. Let me give us some extra space here. Let's just come down. What does this equal? We've got a 3. We've got 2 pairs of parentheses, m and m. Now, last term is negative. Remember, anytime it's negative, you've got a plus and a minus. Now, we know we need numbers that multiply to negative 20, but when we add them, or really subtract them, because they're going to be positive and negative, we get negative 8. So what are your factors of 20? Let's just list them out. 1 times 20. And you don't have to list them out on your own assignment if you don't need to. If you don't need to get it right, then don't. There's my possibilities. I can do 1 times 20, 2 times 10, or 4 times 5. Only one of those will subtract to negative 8. It's right there in the middle. Positive 2, negative 10. I need the 10 to be negative because it has to add up to a negative 8. And there's my answer. Do not omit the 3. The 3 is part of your answer. It's out front. It's there. If it weren't there, it would have been a different problem to begin with. Okay? That should do it. You should theoretically be ready to do all of the problems on the assignment now. Good luck, and I'll see you in the next video.